work right now at Hebrew University with Iran Eldar, working on sort of computational psychiatry broadly, but in particular the computational mechanisms of worry. He's designed some like incredibly clever tasks that are really providing all sorts of interesting insights. If you like the two-step task, he's got two-steps task squared, which is the four-step task that I think he's going to be talking about today, and lots of just like really cool cool designs. And also just some like incredibly cool ideas about how to take a computational approach to understanding worry. So whenever you're ready, Paul.
Yeah, thanks so much, Pete. And thanks for the opportunity to talk. I'm pretty excited to share some recent work and some pilot studies that are really like fresh off the press. So that'll be like the latter, really half of the talk. And as Michael asked, feel free to interrupt if you have clarification questions, if something inspires you to have some new ideas, especially with the work that's sort of in progress. I'd love to hear your thoughts. So yeah, so the basis of my work is a relationship that seems pretty intuitive just in our daily lives. There's a relationship between planning and thinking about the future, imagining the future, and worry. And so this has been something that has been observed for decades clinically. It's if you think about it, worry can be thought of in and of itself as imagining something dangerous in the future and trying to come up with a possible plan or solution to avert that dangerous outcome. And this is, I think, a really nice sort of summary statement on how that process can go wrong for people that feel that they are worrying too much and they're not in control of their worry. So this is from a clinician scientist, Andrew Matthews, who wrote in 1990 that individuals that have problems with worry are constantly rehearsing that future danger without any sort of tractable solution ever being found. So I began in clinical psychology, in a clinical psych PhD program, and a lab that studied anxiety from a neuroscience standpoint. And as I started to get more interested in specifically what causes worry, these ideas were at the forefront. And I was somewhat surprised, somewhat not surprised, to not see these ideas being rigorously tested in an experimental setup. And I think that's because, generally speaking, I didn't see or hear a lot of sort of like granular information processing or algorithmic thinking when it came to like what is planning in the first place and how might it go wrong in worry. And so this was towards the end of my PhD, and I sort of started off with this crude information processing or cognitive model of how to think about worry from a planning perspective. So the process starts off with a threat identification, and then you simulate in your mind possible behavioral policies that might lead you to avoid that threat, which is what you want. And then there's presumably some internal threshold that if you meet it, it means you have composed a good enough plan and you can sort of terminate this process. But if you don't meet that threshold, you go back to the start of the simulation and you try to search in your mind for ways to avert that threat. And you can see how that sort of latter pathway, even though it's crudely described, if we can formalize it and understand it better, more precisely, it might help to explain the core feature of worry, that it's repetitive and it seems uncontrollable. So as I was taking this perspective more and more, and myself learning about reinforcement learning, what it means, how to use it, how to apply it to the problems I was interested in, I began to come up with a little bit more concrete hypotheses within the framework of model-based reinforcement learning in terms of what specifically might be going wrong, to then be able to then think about, how might we measure these in the laboratory for people that worry. So this is the classic Bellman equation, I'm sure most of you are familiar with. And on the right side, it's broken down into sort of its component parts. So when you want to derive the value of your action in your current state, you simulate the next states you enter, you determine how likely you are to enter those states, what reward or punishment you might receive when you enter those states. And then once you're in those states, what subsequent action, the best subsequent action you could take, because this is about the cumulative reward you'll get from your current action. And so to me, these yield different hypotheses about what might be going wrong for people that worry. So you can think about worriers as having a sampling bias. They might undersample positive events or states. The cognitive map that determines state transitions might be off. So they might think that rare negative events are more likely than they truly are. And there's a ton of clinical evidence to suggest that's the case. They might have a different reward function in certain ways. So even though this is a big question in sort of reinforcement learning, where do these reward functions come from? Some have suggested some of it's internally generated. And so you could think of a person who worries a lot, getting neutral feedback from the environment, but perceiving it as punishment, like some sort of ambiguous social signal. And there might also be pruning biases. So someone who's planning 2 steps in the future, they might not think about the 3rd step. And so they might predict some dangerous outcome, but if they were to roll out planning further along in the decision tree, they might recognize that maybe that is the best way to get them out of this potential threatening situation. And so that's just at the control level, the internal dynamics of how we derive our plans. But I think there's potentially even more interesting questions one level up. So I'll be talking a lot today about the meta control of planning. And I'll talk about 2 basic components of meta control. I list 4 here. The first is like, how do we even set our goals over which to plan in the first place? How do we switch between multiple goals we're planning for? How do we delay planning? Because planning is a costly process and we have limited cognitive resources. So if we're sitting in bed at night and deriving a plan might not be that advantageous in the immediate future, why do some people engage that exhaustive process at that point in time? And then how do we terminate a process when we search through many, many possibilities? And it seems like we're not going to yield a better plan. How do we terminate the process? Because we're incurring a cost if we keep it going for long. Okay, so what is computational psychiatry taking this approach said so far about the relationship between planning and worry? So the way I sort of think about this as a shorthand is that we have some well-validated and meaningful tools that have something to do with planning in the sort of implied reinforcement learning area. But it's been really limited when you think about how to design tasks and understand how complex planning is implemented in the human mind, how it might go wrong for the question that I'm concerned with. And so we've basically relied on the 2-step task. I'm not going to go into details about the 2-step task. I'm going to assume this audience really knows what that consists of. But what I want to do is I want to contrast features of the 2-step task to the features of planning problems in a more ecologically valid setting that I think might yield a better opportunity to observe and to characterize planning problems and worry. So in the 2-step task, you essentially have one goal. You're thinking about, once I enter that 2nd stage, what's the best action I can take to get the most reward? But in daily life, we're managing multiple goals with different reward functions potentially. And we have to allocate resources efficiently to all of them if they all somehow sum up to our overall well-being. It's also a really shallow planning problem. I mean, obviously, when we think about like an adolescent planning for how to get into college, there's many different steps along that process that they have to think through in order to achieve that goal. And under that context, you think of like how you might prune decision trees in sort of adaptive ways, how you might consider larger or narrower breadths of actions. But that really isn't an issue in the 2-step task because it's a simple form of planning that's really always optimal. So you don't really think about the cost of model-based planning within the 2-step task because it's the optimal strategy. And it's not something that is terribly costly, at least in this context. But in daily life, like I said before, you might want to.
All right, can I interrupt for a second? I mean, and tell me if this is not relevant, but the standard 2-step task is actually not optimal to be model-based. The way that they set it up, often you can do just as well if you're model-free. I think there's some papers on that. I think
Right.
Barry Cushman and there's a I forgot who it was. Some people from that group found out how to like tweak it to make it more important to actually do model-based planning. So in that case, the cost, there's the cost of mental effort. If you can do just as well from doing model-based planning, is that something that's relevant to this discussion or not?
Yeah, for sure. For sure. I guess I'm assuming that once you sort of tweak the task, like the newer versions, I think there was I think Patzelt is the last name. I'm remembering it from a paper with Sam Gershman where they incentivized the two-step and they saw people using it much more. So yeah, there is some cost in this task. And when you incentivize it better, you see that maybe out-competing the effort cost, the cognitive effort cost. I still think there's I guess a wider range of costs that we can pursue with more complicated tasks. And the question is it, no, the point is really well taken. So you get some variation. And I guess the empirical result so far is that variation so far hasn't been enough to maybe reveal the kinds of relationships that I still think exist and that might only be apparent when you make the task a little bit more complicated. Cool. So just one sort of general point that I think about when I sort of contrast from sort of first principles how to design a task that's really focused on planning complexity versus the two-step. I think about the two-step as really focused on how you leverage your knowledge of the cognitive map or the task structure to assign credit to your actions better. So for instance, if you get to the second stage by a rare transition and that action is rewarded, you should use your knowledge of the task structure to go back and update the action you didn't take, because that's more likely to get you to that stage on the next trial. So it's not really, in my view, it's not really about sort of the complexity of these sort of termination and delay and all these kinds of meta control steps over planning that I'm interested in. Although people have worked on this. So my work builds on work by Quentin Hughes and John Reuser, where they have these really elegant and more complicated designs to study how people prune deeper decision trees in complicated planning problems. And so that's the basis of what I'll talk about today. All right, so I'm going to start off with one area of how we exert meta control over planning, and that has to do with goal management or mismanagement in the case of some clinically observed phenomena in people who worry a lot. So two very broad areas here are the setting of goals that might be too difficult to achieve, and the overinvestment in certain goals to the detriment of others when we have to manage multiple goals with our planning resources. So you can think of the first one as an adolescent setting some ridiculously difficult goal to reach, like being the best at some athletic sport. If they don't have certain traits that make that more likely, maybe that's too difficult a goal to try to achieve. And you can think about how that might tax planning resources too much if they're trying to find the solution, but doesn't seem to be working and they overexhaust. And so it's been clinically observed that this kind of perfectionism is associated with a tendency to worry a lot. In the second area of goal management, you can think about the overinvestment in certain goals to the detriment of others. So for instance, there's a lot of work showing that adolescents who focus on getting a specific grade in their academic environment, if they overinvest the resources in that, other areas suffer, and it's associated with greater worry because investment in getting that goal may make it more of a priority to find an optimal plan, which might be harder to find. And it also might create other worries from not devoting resources to other goals that are important for their overall well-being. So how do we leverage this idea in a study? We used an application of a simple banded task in a multi-goal context to study how people might perseverate on certain goals to the detriment of other goals. So the intuition here is that worriers can become stuck in planning problems they prioritize more. So if an adolescent's highly invested in avoiding some social conflict at a party that's occurring later that day, they might be stuck in this planning problem when they have immediate tasks right in front of them throughout their day. And it would impinge on performance on more relevant tasks to them. So how do we go about doing this? We had subjects manage two goals. This was recently published with a bunch of colleagues from our group in my former group in London, where they had to manage switching between punishment avoidance and reward pursuit goals. I mean, we wanted to try to characterize computations underlying the perseveration on punishment avoidance when we were telling them to just pursue reward. And so we collected a large sample online and we measured symptoms of worry along with other forms of anxiety and OCD. And so I want to walk through the details of the task as a basis for understanding what we found. So participants are told in this task that they need to learn the likelihood of encountering black and gold features behind two circular doors in order to win points. The doors are depicted here on the decision phase, where participants have the choice to open the left door by clicking G or the right door by clicking J. Behind the door they choose resides any combination of features, none, one, or both. At the start of a trial, the participant is told the point value they receive for each feature appearing behind the door they choose. So here, if they encounter a black feature, it will take away 1 point, whereas seeing a gold feature will neither give nor take away any points. So the goal in this trial is to avoid the black feature. And over the course of trials, subjects learn the probabilities of which features occur behind each door, and those probabilities drift, they change over time. So participants learn through post-decision feedback. In this example, the participant chose the orange door, which moves up to reveal the features behind it, followed by what point value each feature has. And in this example, because a black feature is behind the door, the subject lost a point. After the feedback on their performance, the door they didn't choose rises to reveal the features behind it. And to do well on the task, participants need to use all of this feedback to update their estimates of where these features tend to reside. And participants faced one of two goals that could switch every trial. So this forced subjects to learn about all features to be prepared for any goal that they could face on the next trial, which they didn't know. So an avoid punishment feature is the one I just went through. And a reward pursuit goal is sort of the opposite, where if they encounter a gold feature, they are rewarded 1 point. And the black feature essentially doesn't matter. They don't win or lose any points if they observe that. Okay, so how did we quantify the perseveration on goals that aren't relevant to one's current circumstances? So I'll just go through an example to deliver this intuition. Let's assume participants have estimated up until this point in the task that choosing the right door is likely to lead to both the reward and punishment features, and the left door to neither of these features. So consider the case where they're instructed to pursue reward. Given their knowledge, they should choose the right door, as it leads to reward. However, participants may be transfixed on the irrelevant desire to avoid punishment, even when they're instructed to pursue reward. And this irrelevant desire to avoid punishment can actually intrude on current experience, reflected in choosing the action that leads to the avoidance of punishment, obviously to the detriment of missing reward. And one other key distinction is that this isn't an approach avoidance conflict task, where individuals simultaneously confront the risk of punishment and possible reward. So here we instruct the participant, there's no possibility of danger on this trial, and yet it's still possible that they seek to avoid punishment. And this may reflect participants practicing how they would avoid future punishment, which we think may relate to why individuals who worry a lot are internally simulating future danger that isn't immediately relevant to their current circumstances and might impinge on more immediate goals that they face.
Paul, can I just ask a quick question on that?
Yeah, sure.
So sorry, what's the cue that they get that tells them whether they're in a punishment avoidance? Is it just the words that say that there?
It's not even the words. So the actual trial looks like this. So if you're following the laser pointer, it looks like this right up here. Yeah.
Okay, so
and that switches.
It's presented during the entire phase of their choice. So there's no like memory demand or anything like that.
Exactly. Yeah, it's completely visible throughout their choice. Yeah.
Okay, because I mean, my question is like I can see how like if you encode the rules perfectly, then there's no approach avoidance conflict. But I was wondering whether like if you are, you know, a bit confused, then you might say, well, I haven't quite mapped everything properly in the right matrix in my mind, and so I can do whatever I can to just avoid punishment or something.
Totally. Yeah, that's a great potential alternative explanation for some of the effects we observed. And we actually got that in the review process. And we had a sort of attentional lapse model that didn't do as well. I actually forget there was a distinct behavioral signature that we didn't find that was consistent with that attentional lapse, that they just weren't, seeing the instructed goal, but it didn't work out as well. Yeah.
All right, thanks.
Yeah, no problem. All right. Okay, so just some more reasons why this multi-goal learning is taxing. So individuals need to keep these running estimates in their minds of how likely each door leads to these two feature types. And when they face an instructed goal, which could be to pursue reward, they must internally activate only the relevant probabilities for that goal, which for this one is just how likely each action leads to the reward feature. And then after getting feedback, they have to update their estimates of all these features. So even though on this trial, the punishment features weren't relevant to the decision, they might be in the future. And so they need to do this sort of full update. I'm just going to give a little bit of detail into the more formal computational model that underlies the sort of two key systems I'll be talking about. So I'm going to present a model-based agent, how they plan, how they derive their action values, to then highlight what's unique about the agent that perseverates on goals, despite what's instructed. So here the model-based agent wants to avoid punishment.
Can I ask
which
another
is
clarifying question?
Yeah.
Thanks. Sorry, I maybe I missed this, but do you have any check on whether they assumed or they understood that the gold feature behind one door was the same as the gold feature behind another door?
I actually don't think we had that check. So you're saying, are they all, the gold feature behind one door is, sorry, say that again?
Oh, well, sorry, maybe I misunderstood what you were saying just a second ago, but I thought you said that, after you observe an outcome, you update both the gold feature behind door one and door two. But I guess that's because you provide the counterfactual, right?
Exactly. Yeah.
Okay. Yeah. All right. Thank you.
But the
No.
on a given trial only affects the probabilities of the one door, correct? Right, like so you wouldn't have to also update the door two. Right, would you just if it's your estimate is 2010, you just need to estimate, update that one, I think.
Okay.
Yeah, so there's no dependency between the random walks over the four feature probabilities you have to learn. It's like, given the action I choose, what's likely that I see a goal feature behind this door? They're all independent of each other. Okay, cool. Yeah. Okay, so hopefully that's clear. So here the current goal is to avoid punishment, and the agent is going to plan on the fly the value of each action by taking the dot product of that goal vector with what they know about punishment features in the matrix preceding it. And the 0 in the goal vector means that reward is not relevant. So you're essentially canceling out, your knowledge of reward. Your knowledge of reward features shouldn't influence your decision if you're fully model-based. Okay, so this is the main contrast between a model-based agent and a goal perseveration agent. So the goal perseveration agent has the same exact knowledge of where these reward features are given actions as the model-based agent. We tried different models where they were, this subsystem was learning these feature probabilities independently, and it didn't do as well. The only thing that's different is that the goal vector never changes. A goal perseveration agent is always seeking reward and always trying to avoid punishment, but to different degrees, because we have these inverse temperatures here. So if this one was at 0, this could mean they're never perseverating on reward, but they're perseverating to some degree on punishment. So their desire to avoid punishment is influencing their decision-making when they're instructed to pursue reward. And that's the sort of part of this that I want to keep with you, because that's related to the key finding. Okay, in relevance actually to the earlier point that Michael made about incentivizing the task to make sure that your strategy that you say is optimal is in fact optimal. We demonstrated that with the model-based strategy. It's optimal. That's the blue bar on the left here. And here's the goal perseveration strategy, assuming equal inverse temperatures for both reward and punishment perseveration. So it's a little bit better than model-free, but it's not as good as a model-based agent, because that perseveration is going to interfere with pursuing the instructed goal on some trials. These two bars are hybrid agents. So the orange bar is an agent that's pursuing punishment when they're instructed to pursue reward. So they're perseverating on punishment, but they are fully model-based for reward. So they do even a little bit better. And so this graph gives a more precise view of the cost of a GP strategy, which we simulated here, simulating this green agent here. So on the y-axis, you see the likelihood of switching your action on the current trial from what you chose on the last trial, as a function on the x-axis of the features that you observed given the action you took on the last trial. So let's consider an agent that is seeking punishment, seeking to avoid punishment even when they're instructed to pursue reward. So this is these dark green bars. In the last trial, you were told to avoid punishment, and on the current trial, you're told to seek reward. So here they should only focus on whether on the last trial they observed reward, which would motivate to stay with their last action, right? Because it's rewarding, or they did not observe reward, which would motivate switching because it's not a rewarding action. However, for an agent that's perseverating on punishment, they switch less when they did not observe a reward in terms of whether the situation was safe, right? So here in the left part of the x-axis, they did not observe a reward. They should be switching at the same rate, but because this one doesn't have punishment and you're seeking to avoid punishment, it's considered a bit safer. And it's sort of the opposite situation here. They observed reward for this action on the last trial, but they're switching more here because they also observed a punishment feature. And this agent that's perseverating on punishment also wants to avoid punishment. And this isn't the case for a model-based agent. So here, regardless of whether there was a punishment feature or not, they are staying more with the action that led to reward. So you might ask, okay, despite this cost, what are some benefits of an agent that's using this perseveration strategy for certain goals? And we can show through simulating this agent that even though this goal, let's say an agent that's perseverating on punishment, it's cheaper to use than a model-based agent because it essentially avoids needing to switch off the avoidance of punishment given the instructed goal. You can do just as well for the goal that you care most about. So let's consider the case of punishment avoidance. Scientists in evolutionary biology and psychology have hypothesized and found some evidence that humans might prioritize punishment avoidance over reward pursuit because if you miss an opportunity to avoid punishment, that can be fatal, right? And so we show in simulation that an agent that is perseverating on punishment does as well as a model-based agent at avoiding punishment, but to the detriment of pursuing reward. They're earning less reward here. This is just the orange bar, and the blue bar is a model-based agent. And interestingly, in our full sample in this study, we found that in line with this evolutionary hypothesis, individuals in general are perseverating more on punishment than perseverating on reward. And most interestingly for my work, we found a specific relationship between the endorsement of worry symptoms and the tendency to perseverate on punishment. So we see this as evidence that individuals who are prioritizing punishment avoidance more in their worry are perseverating more on those goals. And it may be part of the explanation for why worriers are getting stuck in punishment avoidance problems, even when those problems are not relevant to their current circumstances.
Paul, I think Dan has a question, and then I also have one after.
Sure. Hey, Dan.
Thank you. Yeah, just actually a couple of brief ones. One thing that I didn't totally understand about the slide even before this was,
Sure.
Yeah, so these I was a little bit confused about. I mean, I guess mostly just because it was a lot to internalize pretty quickly, but also because my intuition would say that there would be some sort of time course, so like depending on the model parameterization, and I don't mean this to be like a nitpicky model parameter question, right? But I just mean, I'm interested in how different these types of results are on the basis of, how far into sort of asymptotic learning you are versus where you are along that learning curve. Because I would imagine this type of effect would be sort of like maximized in really early trials or something like that, right? Whereas over time, you're learning values that are more, assuming that the models converge to good values, and maybe they don't, I don't know. So these are sort of the questions that I had about this. Can you say something about the sort of time course of these models?
Yeah, it's a great question and not nitpicky at all. So one key feature is that it's not like a stationary task where the latent reward rates are constant and you're getting to that. So the feature probabilities themselves are drifting over time. So I think there would be these time dynamics where over a certain period of stability, you would see it earlier on, but then they change. It's not stationary. So once they change, then you start to see those effects emerge again. Just in terms of like to make this more transparent, we use the learning rate that was sort of the average in the group population to do these simulations. But yeah, if we were to titrate that up, you might see even more dramatic effects from sort of last trial effects, right? Because the learning rate was quite low. The drifting of the feature probabilities was quite slow.
Yeah, okay, that's super interesting, because I guess I would expect that then you would have a pretty strong interaction between the learning rate and the drift rate of the underlying stochasticity. And that seems like potentially a pretty interesting thing for individual differences in terms of actually avoiding real world punishment, right? But anyway, that's an aside, I suppose.
Yeah.
Okay, I think I just had one other quick thing to ask.
Sure.
It was about the later ones. Actually, yeah, never mind. I'll let Michael go. Thank you.
yeah. And I'll just say that we have a study on the ability to learn task structure in OCD, and we found that there's a misestimation of state transitions. It's different depending on whether the state transitions are stationary or not. So we have another paper if you want to look into individual differences in learning rate for the avoidance of punishment, and here even the pursuit of reward. We have stuff on that, so check that out.
Totally. And you know what, you actually reminded me of the quick version of the question that I wanted to ask, which was just
sure.
For the have you looked into like misestimation? It sounds like you have looked into model misestimation a bit. And so I mean, a thing that comes up to my mind is that if costs are always more costly in some sense than benefits are, right? Because you can always die or whatever. Then you can imagine that there's a strong, that misestimation can present a real risk, and therefore that in these types of that there might be a normative way that you could look at that with this, with the relative reward earned for the punishment perseveration versus the, so like if your model is wrong, does that bring your model-based reward down to the level of the cautious punishment perseverating strategy or something like this?
Yeah, I see. That would be really interesting if a reliance on a less costly strategy was a function of model misestimation. I don't think we found any evidence for that, at least in warriors. But it might be the case because we know that individuals with higher levels of OCD are experiencing model misestimation.
Okay, yeah, cool. Thanks a lot.
Yeah, great questions.
So my quick question is, I'm just trying to understand the result. Is that correlation with worry and so forth? Is that a parameter, or is that like the extent to which those people are better fit by the goal perseverer model on punishment compared to the other ones?
Yeah, so this is just from a multiple regression. It should be taken with caution because there's a multiple comparison issue here. So I sort of see this as preliminary evidence, but it's a multiple regression where we're predicting worry as a function of several parameters in the computational model. So we just extracted each participant's posterior mean for each parameter. we found that was the significant relationship that came out.
Yeah, sure. I guess so. Okay, so that sounds like your model is a hybrid model that has some degree of goal perseverateness for punishment, but also the ability to have full model based. Because I thought the way that you presented it before was that you have an optimal model based model, you have a separate model that is only goal perseverative on punishment, a separate one that's only on reward, and so forth. But
Oh
what you
yeah,
just
sorry.
said- yeah.
Yeah. The winning model is a hybrid model where you have different levels of model based, model free, goal perseverative, action perseveration. Yeah. So I'm just looking at the subsystems just to get an intuition for how they're different. But the winning model has different levels of each one of those strategies.
Okay, awesome. And then did you show that model captures the kind of qualitative behavioral patterns that you were showing on the last slide?
Yeah, exactly. Yeah. So we have a linear mixed model in a Bayesian framework that essentially provides evidence for the qualitative behavior that you would associate with each one of those strategies: model free, perseveration,
Okay.
and it also mirrors what we found in the modeling. So in the linear mixed model, we found that there was a greater effect of punishment perseveration and only a trending effect for reward perseveration, and that's what also came out in the computational model.
Awesome, thank you.
Yep.
So, Paul, I was just wondering how you think that this result, whether it may or may not relate to sort of certain cognitive individual differences. So I think we've talked about this, but there's big clinical, science literature on ideas like, difficulties impairing negative content and working memory. Inhibiting negative content and working memory, and also just like impaired disengagement hypotheses of rumination and worry, various cognitive tasks supporting that. So do you think that this task ends up tapping into sort of that individual difference? And if we had strong enough task psychometrics that the same people who, were higher on the GP punish parameter would also show stronger differences in those tasks, or do you think it's sort of tapping a different system?
Yeah, I think some of the explanations for some of those task interference effects are sometimes hard to know why that's happening. You can imagine just someone who's actively worrying, their working memory resources are depleted to be used for the current task, and I assume that that's the case for a lot of warriors that are doing cognitively demanding tasks, and therefore I would assume that this perseveration parameter, which might be capturing the intrusion of worry, might then predict sort of interference of whatever naturalistically is happening for these individuals that impairs their performance on cognitive tasks. That's sort of a first pass hypothesis. In terms of like why they I guess there could be several causal explanations for these working memory impairments, and I doubt that this is capturing all of those reasons.
Because your kind of working idea was that the perseverators, it might actually be sort of bringing the same task set to the irrelevant trials and sort of rehearsing that, and you might even, like, if you were asking them about their thoughts, they might even be explicitly rehearsing that more. Was that the idea?
Yeah. So in like so there is like my former lab studies, like they found that there's a specific relationship between warriors and the ability to switch between tasks. Like they're worse at switching between tasks. So what you just said, well, it would predict a general sort of perseveration, that they would be perseverating both on reward and on punishment. But we found a valence effect. So I think that that's relevant here. So I think there's probably other reasons other than what we found for maybe a more, but it's tentative. I don't think that this has really been solved yet in that literature. If there's enough evidence to say that there's task switching problems, let's say, in warriors.
Yeah, especially whether it's only, because it doesn't seem like it's generally task switching if it's only in the context of negative valence, and that still seems like a pretty open question to me.
For sure. Yeah, totally agree. Yeah, but yeah, I think this, I haven't yet thought about all the implications, I guess, of this explaining different, more specific task switching problems. Yeah. Cool. Thanks so much. All right. So for the first half here, I've talked about this failure to disengage from certain goals, the ones that we think warriors are over prioritizing in their daily lives, the avoidance of punishment. And so I'm now going to pivot towards new work that we've done. This is all pilot data. This is all fresh, where I designed a task that attempts to measure the optimal delaying of planning. And the intuition that I think is helpful to take along with you to connect it to the clinical questions that motivate this work is, if planning for some future danger isn't helpful, why are you worrying right now? All right, so what did we do? I developed a 4-step task that's depicted here on the right. Every single arrow there is deterministic. And the first decision is between the trident or the planet. That's the first decision of the 4. And so they first learned this map. And the way they learned it was they were dropped in randomly to a certain place in the map, like for instance, the watch or the north symbol. And they just took 1 step. And then after that, they were randomly inserted into some other area in the map. And we tested them on their knowledge of these 1-step transitions. And the reason why we didn't have them go sequentially in training is because we wanted to remove the chance for them to learn a non-online planning strategy, like using a successor representation to derive their action values. And so after they learned, they entered a planning phase. And like I said, the first choice is between the trident and the planet. And they had 20 attempts to reach each of these goals. And I'll sort of get to why in a second. This allowed us to infer whether participants optimally delayed their planning. All right, so the punchline here is that the map was constructed such that each future goal they were instructed to try to reach had an optimal planning depth. So here, if they're told, you're going to win a lot of points at the snorkel image, they have to choose the planet as their starting state, because if they don't, there's no route that will take them to that goal. And the planning depth here is 3, because the key state they need to get to is the palm tree to get to the eventual goal, which is the compass. But either the trident or the planet can get you to the palm tree, so you can start off wherever. And so on and so on. This has a planning depth of 2, because you have to get here, and each action can get you there in the preceding stage. And finally here, you can just leverage your 1-step knowledge to get to the houses at the final step. Okay, so, whoa, sorry about that.
Wait, sorry, that seems pretty fundamental, so.
Yeah.
Doesn't that assumption assume that you're planning backwards from the goal rather than forwards? Right, because if you're doing a forward tree search, then you have to go all the way down to know that there was actually a 1-step, that you could have just reduced it to 1 step. If you start from the goal and go back, which I know there are algorithms that do that, but.
Yeah, so this is stuff that I think I realized later in sort of forming the algorithm. But I think what you're pointing out is that there is potentially a crucial difference in sort of the first time you plan this out, and maybe the second time you plan this out, that there's just sort of learning through initial planning where the optimal starting point is. So like you said, if you're a forward planner, you would need to plan from both actions to then realize that you only need to start planning at this stage. But backwards planning, yeah, it would be easier to come to that conclusion, I think, if I understand you correctly. Yeah.
Yeah.
Yeah. So,
but yeah, I mean, if you're always, so you're saying that even if you're a forward planner, you might realize in that first time that you could have just done it in reverse, and that would be more efficient for computation, and therefore you should switch to reverse planning to figure out the depth of the tree that you need to go through. Is that the idea?
Yeah, I think that's one possible option, that you make the inference that you can use backwards planning after that initial sort of exploration in like the first trial when you simulate forwards. I think also, like, I mean, this is what we can get into in the end. If you simulate from both actions, on the first time you face a goal and you realize that there's no difference in either of the action values, your sort of meta controller can say, if there's no benefit to planning at this stage, I've tried it out once, I've done the full tree, then the next time I encounter this goal, I don't need to start planning here. I can plan at the next step. So these are like temporal dynamics of how the meta controller would come to the inference that you don't have to plan at a certain stage. And I think that there probably are different ways that happens. So there I'm suggesting that maybe you don't ever need to engage backwards planning. You just have to go through it once from a forwards plan, tag the stage that doesn't benefit you when you plan, so that next time you don't plan there. That makes sense?
Yeah, well, that makes sense for that one goal, but if you had a different goal on the next trial, you would still have to do that again, right? You can't-
Yeah, so it's like totally. Yeah, exactly. So this would be the next time you encounter the same goal. So in this planning phase, 20 times they encounter the same goal. So there's 80 trials, 20 times for the snorkel, 20 times for the compass, and so on.
Okay, yeah, got it.
Cool. Yeah, it's a great question. Okay. So I'm going to try to do this. I unfortunately had a timer on this that is messing with the slide. So this is what a planning trial looks like. So the question becomes, like, how do we behaviorally measure how people delay their planning? So on each trial, subjects are told that they have this one final reward at the end of the decision tree for a given goal. But in addition, at each decision out of the 4 decisions, they can have the computer choose their action randomly for them. So the logic here is that if you don't need to plan at this stage, you should give up your control, because you're going to win points. And, you know, if the depth of planning was just 1, you could just plan at the last decision. You know, you'd be gathering immediate rewards for the first 3 decisions, and then at the end you get this big reward. And so we're incentivizing them to delay their planning if they can. If they on 3 out of the 4 goals, if they just give up their control on each trial, they're missing a lot more money they can get, because they're going to miss that final goal. And I'm just putting a sort of disclaimer that later on I'll show evidence modeling reaction time that individuals are not just delaying control at these on trials where they're choosing to, but they're also delaying their planning. And we can get at that with reaction time.
Paul, can I also ask a question?
Sure.
So the computer plans then all the stages. So it's not like you can first give up control and then see what happens and then regain control. You have to choose it all or nothing.
That's a great question. Thanks for asking that. So that's not true. So you can gain control on every trial. So let's say you give up control on the first trial because you've inferred you don't need to plan there. Then on the second trial, you can start controlling and execute some plan that you think might be necessary to get you to your goal.
Okay, but then for one trial is one entire tree, right? One entire decision tree is one trial.
No. So participants are taking 4 decisions within a trial. So they start off at the top of the decision tree. Do I choose, their first decisions, do I choose this and this? If they give up their control, maybe they end up here, and then they're faced with another decision. Where do I want to go to next? And it's the same information on this. It's the same goal that that's being displayed to them that has the big reward. And they're given the option to give up their control. every decision. 4 decisions per 1 planning trial. That makes sense?
Yes.
Cool. Yeah. Now I see another question. Yeah.
Oh, yeah, sorry. Is that me that you see?
Yes. Yes. Hey.
Okay, cool. Yeah, how do you distinguish? I mean, so I've been thinking a bit about the same thing that Michael was thinking about with the forward and backward. And so how do you distinguish between like an amortized planning situation where like I've thought through, you know, the states enough? I mean, yeah, I guess you're gonna talk about planning versus control in terms of reaction times. But the thing that immediately jumps to mind there is like, well, my reaction times are going to be reduced if I just remember basically the structure of the thing, or have, you know, chunked it in certain ways or something like this. Is that something that you can control for, or maybe I'm jumping the gun?
Yeah, no, it's a great question. I mean, I anticipated like vacillating between the sort of bigger, more sort of precise algorithmic questions and the sort of descriptive results I'll be presenting. I think it's for sure possible that chunking occurs as the task goes on, and you're just retrieving from memory a chunked plan. I guess what you know, it's an empirical question. Is this map complex enough such that, you know, we're incentivizing them to randomly enter certain spots when they delay their control? So then they have to retrieve a different chunk, right, from that point, right? So there's like many different paths to, let's say, get to the compass. Well, I guess yeah. The depth of planning also factors in here. Like, it's something that I should probably characterize. Yeah, how many chunks are needed to retrieve for a given goal? Like, one thing, for instance, we know is that reaction time is getting quicker the more trials in they go. That's like very preliminary evidence that they're getting more efficient. Maybe they're retrieving, yeah, amortized plans, chunked plans. But to be honest, I haven't thought that far yet. I just want to, you know, I guess what I'm going to show you in a second is preliminary evidence that people are delaying their planning and some issues that we see, predictable problems that we see in individuals that are worrying. But yeah, it's a great point. Yeah.
So just real quick to follow up on that, I mean, it does seem like, if I understand the test right, there should be some really clear signatures of sort of chunking or amortization, in that sometimes they reach decision points where, you know, if they're fully planning, it's just a toss up about which path they can go. But if you see sort of a path dependency of those decision points based on what that subject has done in the past, then that would be a signature of amortization, right? Like, for example, in the one you're showing on the screen, if they get to this decision point and they, you know, and this is the goal, so they can equally pick, you know, like temperature or north. If they keep picking north over and over again, that would suggest that they have that they've chunked it or something like that, right? Like they sort of stored the sequence. This is not the best example because it's a finite depth of 1, but if you imagine that was linked up with you know with another planning depth.
Yeah, so you have to get to north or temperature, right? And so like the idea is, if you're optimally delaying your control, you keep giving up control, and then you end up randomly in one of these, and then you engage your plan. And maybe that's a small enough set of plans that you've already cached in memory to just retrieve it from memory, and it's not actually planning. So the situation that you're bringing up, I think, goes against like the optimally delayed planning hypothesis, where like they'd always be choosing to get to north, and then they're actually not optimally delaying their control, because they're controlling when they don't have to, and they're giving up on reward.
Okay, but yeah, so another way to think about the chunking would be north plus house. You just compress as one thing, right? And then you can use that like unit.
Right. I mean, yeah. I actually, from the one-step transitions they learn in training, they can do that via just like associative learning. They probably have those chunks ready. But I wonder, yeah, the question of like how many chunks need to be maintained in memory and can they juggle all that, I think is a really interesting one. Yeah. Cool. Okay. So on the left is it's a chart that I'm going to be showing you many, many times. So the shade here is the decision point. So this is the first decision in the decision tree and the final decision in the decision tree. And then here's your optimal planning depth on the x-axis. And then a 1 here signifies that you should engage control, and a 0 indicates that you should give up control. So when the planning depth is 4, is full, you need to start planning from the first decision. You should be controlling all your decisions. So you take the exact route to get to your goal. When a depth of 3, you should give up control on your first decision and engage control on the last 3, and so on. And here's an over planning agent that is insensitive to the benefits of delaying their planning, and they're just, maybe they're retrieving chunks, maybe they're deciding to plan, but they're engaging control on every decision point, and so they're losing out on money given the incentivizing in our task. Okay, so what do we do in our first pilot? It's a small pilot. All of these pilots I'm going to show you are small. The distinguishing factor here is that they play the task I showed you, but when they are getting ready to plan, the reward function we show them, like the amount of points they'll get if they reach the final goal, decays as a function of time. Every 5 seconds, it goes down by 1. And so that's supposed to incentivize delayed planning even further. You know, if they don't need to use resources to think through plans, then they can win more money, not just by getting the 100 points because the computer is going to choose their action, but also because their reward function hasn't decayed as much. But the other thing that could happen here, and what we found overwhelmingly, is that this manipulation induces a more stressful environment when they see the reward function decaying. And I'll show you exactly how that impacted results. So here's like an example trial, and here's what they saw. They saw this reward function decaying, and they had to choose between engaging control or letting the computer choose for them. And again, here is just a refresher on what the optimal delayed planning pattern is on the left, and what an over planning pattern looks like on the right. And in the full sample, we tended to see that individuals were failing to engage this form of delayed control and presumably delayed planning. But what was really interesting is that when I divided the small sample up into people who met threshold for clinically meaningful worry and those who didn't, low here on the left, in this planning phase, people who endorsed they worried a lot seemed to fail completely at planning. So this was measured by, for a current goal, were they able to successfully get to that goal given their knowledge of the task map? Oh. Shoot, can people hear me?
I can, but it looks like they're having some sort of problem with in-lab thing.
Okay, I was like, because it was weird because I was getting, facial feedback like you were hearing me, and then I was like, what's happening? Okay.
Yeah, I think they've got like a little thing on the desk, and I think it's fritzed out, and so I think we need to wait for Amara.
All right. I'm happy
we
I
can hear you.
Sounds good. All right, so we'll hold on.
Where did it go and why is it gone?
You hear us?
It sounds
I
like
can
we're
hear-
getting. Sorry. I'll
There we
wait.
go. Okay, can you hear us?
I can hear you now. Yeah, yeah.
That's my camera.
It was.
Oh, the owl. Yeah, there we go.
I don't know what happened.
Okay,
Can you hear us?
I can
I
hear
don't
you
know.
now. Yeah.
Okay, good.
I think just the connection and everything for whatever reason failed. Like to the camera and the speakers in the camera, so we just had to reset everything.
Got
Yeah,
it.
for quite a
Got
while,
it.
so sorry about that.
Yeah, it was like a
I had a question about the last part right before was. Tick, 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 tick.
yeah, that's what happened.
That's my question.
Okay. Yeah, I didn't hear anything. All right, are we losing them again? Oh man.
Losing it again, yeah, okay. I think maybe it being plugged into that was the problem. And then
Well, I'll just ask a quick question about the
Sure.
about the planning depth. I mean, you can imagine planning depth being really limited by some basic stuff like working memory. or attention to the task, and I mean, of course, you talked about lapses earlier a little bit and said, you had models for lapses and all that, but there are other forms of attentional difficulty, right? So do you have some sense based on the worrying and based on this optimally delayed versus over planning situation, to what extent it could be those things, to what extent it could be that like, I forget about the fox when I'm not looking at the fox or whatever.
Right. Yeah, right now we don't have any sort of like measures of working memory capacity, like as an individual difference measure, and how that might explain either just the ability to plan online or to sort of meta plan, to delay planning. So, but that's something we're going to include. We're trying to think of other confounds that might explain, observed relationships I might show you between the tendency to worry and the tendency to either not plan or not delay planning. Yeah, but certainly a very plausible explanation for why people would have more trouble with a task like this that's quite demanding, and that constantly involves switching between different goals. Yeah. So ironically, some of the goal perseveration stuff I presented first might also be operating here, and we want to check that. I know, for instance, that like reaction time is a lot longer following a goal switch when you're instructed a new goal from what your previous goal was versus having the same goal twice in a row. Okay, so you're back. So Michael, were you asking a question? Sorry, I kind of got that mixed
No,
up.
it was just a joke. It was just a joke. You can keep going.
Oh man, sorry for butchering that. All right, cool. Okay, so what I was saying was that in this first study, when there's time decaying reward, it seems like people in general are not inferring when they should delay their planning. Their pattern behavior looks like an over planning pattern in general. And when I split it up by people who are worrying past some clinical threshold in the high group and people who are not endorsing that they worry that much, the worriers are having a trouble planning, like in general, using online planning in this kind of stressful environment. So this was just measured by their ability to reach the instructed goal. So this is interesting in and of itself, that we're observing a sort of planning failure under stress, specifically for worriers. Although this may be like a general stress effect, anybody with any stressful form of psychopathology might also show the same finding. So we can't say anything specific about worry without those, measuring more broadly stress as a confound. All right, so what do we do in the second pilot? We tried to see whether we could just simply observe this capacity for delaying planning when, optimally if we remove the time pressure component. So again, the left is the hypothesized pattern that should hold if people are inferring these correct decision points when they should give up control and where they don't need to plan. And the empirical data looks much better in the group. So here, when the depth is 4, when they should be controlling every action, it's roughly the same for each decision point, and they're controlling a lot. If you compare that to the left, when you only need to start planning at the second decision, which is right here, they're choosing to give up their control much more at the first decision, and so on throughout each planning depth. So that's a really nice result that's in line with just demonstrating that people can infer these optimal points to delay their control and maybe delay their planning. And then we found this it's such a small sample, we can't take much from this, but I'll show you another study that replicates this, where the tendency to worry was associated with a continuous measure of whether people could optimally delay their planning. So the more you worry, the less good you were at delaying your planning when you should. So this continuous measure is like, if you should delay your planning at this point, did you delay your planning? Or did you give up your control? Sorry. If you shouldn't have given up your control, did you not give up your control? And you get a point for both of those. And then if you didn't control when you should have, you get 1 point less, and so on for the last category. Okay, so this is preliminary evidence that individuals who worry a lot are having trouble delaying their planning, right? Which was the motivating hypothesis. We want to just come up with some sort of laboratory task that can measure over planning, more over planning in worriers. Okay, so I've been alluding to this a lot. Is there a relationship between giving up control and delaying planning? So the way that I got at this as a first pass was looking at the reaction time data. So presumably if you're planning on a certain trial, you're using more resources and you should have greater reaction time. And then if you're simply executing a plan, it's going to take far less time because you already have your plan and you're just executing the actions. So we see that nicely here. For a depth of 4, they should be planning here, and then they're just executing their plan on the subsequent 3 trials, which have much shorter reaction times. Then if we take it to depth 3, this is purely descriptive. There are no statistical tests here, so I'm not accounting for error. But just descriptively, at the decision point where they need to start planning, that's where their greatest reaction time is. And the same thing for a depth of 2. A depth of 1 is a little bit more sort of tenuous in terms of what it means, because every single preceding decision where you didn't need to plan and where you gave up control has actually a greater reaction time than the actual decision where you need to plan. But planning here could be accomplished by simply retrieving associative learning that you got from training. And also it's noteworthy that this reaction time is greater than any of the final decisions, when in these trials we're more confident that they're just executing a plan. So it's not, a perfect set of descriptive data but it's suggestive that that when they are giving up, when they are regaining control, they have, at the time point when they have to initiate a plan, it has the greatest reaction time. So presumably they actually are starting planning then. All right, so we also wanted to see if there's a relationship between people's retention. And I think this gets into Daniel's question. The retention of all the trajectories in this map, all the different paths, all the different routes, and their ability to infer when they should delay their planning. Because if they don't remember all these routes, maybe they're undersampling like crucial trajectories that they might need to then infer, at this time point, I should give up my control. And I don't need to plan at this time point. So we had these queries before they started the planning phase, where goals kept switching and they could delay their planning, where we wrote out one of the 16 trajectories and we had them enter the exact sequence that gets you, in this case, from the planet to the fox, to the microphone, to the snorkel. Did they know all of these possible routes, basically, was the question. And what we found was that, after even eliminating people from, other different measures of their ability to plan, the extent to which you remembered all the trajectories, you were better at delaying your control when you should, and presumably delaying your planning when you should. So there's a relationship between knowing all the routes in the map and the ability to make the key inference of when you should give up control and when you should delay your planning. And then continuing this relationship with what we found with worry, the extent to which you worried more, you had less ability to recall all the different routes within the map. So when you run a mediation model, for instance, even though it's such a small sample, the relationship between worry and being worse at delaying your planning and therefore over planning is mediated by knowledge of all the different routes in the map, which is a little bit, it's interesting, but it's sort of less interesting. I started this study off with the hypothesis that worriers and non-worriers could, retain and be able to plan all the different trajectories. But what was specific was there was this meta control failure in worriers. So it kind of gets in the way of that motivating hypothesis. So in the final study I'll present, we wanted to try to, okay, before I get into this, Daniel, you have a question?
Yeah, just quickly, I forgot, how many trials were there? Because I noticed on the previous one that you had like basically at ceiling a lot of the performance. So, max quiz, there were a bunch of people who got 100% correct, it looks like.
Yeah, so what's important is that these are, right, these are just for the quiz questions. These are not in like
Yeah.
the planning phase, right? So this is just, we throw out a
Mhm.
trajectory, do you get it? It was just one, each possible route, so there's 16 routes, had its own quiz question. So there were 16 quiz questions. So they only had one opportunity to get it right.
But how much did they practice in the, that was the part that I missed. Like how many trials of the actual task had they done?
Got it. So in the task, they never do full trajectories. They just take one-step transitions when they learn. And
Mhm.
they only, they had, I think, somewhere around like 240 trials, maybe more. I should get that number right, but it's something on the order of 300 trials.
Gotcha. So they sampled every transition, like, some tens of numbers of times.
Yeah.
Okay.
Yeah, but I
just
no, it's a good question. Yeah, I mean, this was a pilot. We're still in sort of that calibrating step, right? Part of this quiz was exactly getting at your question. How many samples of a given trajectory do you need to get them to ceiling, which is what we wanted, and that is what we changed in this upcoming pilot. So because this is a simpler task, this is 3 steps. There's only 8 routes. They are experiencing more of those routes, given the same number of trials, essentially, relative to the previous pilot. And then another way that we tried to ensure they actually knew all the routes in the map was that every 80 trials, we did those quiz queries. So now they had about 4 quiz queries per route, something like that, maybe 6, I forget the exact number. But by the end of that kind of training, everybody was at ceiling. Okay, so this was not going to explain any variation in the ability to infer when they should delay their planning and delay their control. So here, because it's a simpler task, on the left is the theoretically predicted pattern if they're optimally delaying their planning. And on the right is the actual empirical data. So there's, again, evidence that they are delaying planning when they should. They're giving up control on the first trial when the depth is 2, and on the first 2 trials when the depth is 1. So that's nice. And then I had a stronger approach to modeling the reaction time data to try to get a stronger inference as to whether or not the giving up of control also meant that they weren't planning, and when they re-engaged control at the decision point where they had to start planning, they were in fact planning at that time. So I predicted the log reaction time from several predictors, like the trial number, the depth of planning for each goal, the decision point 1, 2, or 3, whether or not the trial was a goal switch, and whether or not the trial required control. And the 6th one is a little bit confusing, so we can kind of ignore that for now. But the key variable to get at the key inference was, did participants have greater reaction time when they should initiate planning at the critical decision point, if there was also behavioral evidence that they gave up control or that they re-engaged control at that same time point. Okay,
Paul,
so fun.
I have a question regarding your
Sure.
decision tree for this 3rd pilot project. Did you
Sure.
look into how much more risk the entire decision tree is composed of compared to the 2nd pilot? Because as far as I remember, you had some icons that were, it didn't really matter where you would end up, you would always get to the house. But here the structure of the decision tree looks different. So for me, intuitively, it seems to be a bit more risk related. So maybe all the decision times experience a shift compared to the 2nd pilot, the data in the 2nd pilot. Did you check that, or is that intuitive?
I think I'm getting, you're talking about like, if there's more risk, then you'd see like a distribution shift in reaction times.
Yes,
Is that the?
I think the entire, so for me, from my perspective, the entire decision tree in this 3rd pilot seems to be composed of more risk. So I would be more prone to keep control compared to how I would have reacted when you would have presented me the decision tree in the 2nd pilot.
Yeah, that's interesting. I think that That is true. So so if I were to plot the optimal planning depths here, these two both have a planning depth of 3. So you need to control on each action. I ended up excluding one of these when I brought it to the planning phase, but you're right. I mean, if they're somehow coming up with some sort of like computation of like how much I should control my behavior given what I know of the entire map before they start planning, that's interesting. Yeah, maybe this promotes more control. I mean, I have to think of some way to sort of compare, because on first brush, because it's simpler, there's a greater average score of like delaying your planning, which involves giving up control. So even though there's more risk, like you're saying, and I think that's true, because you need to control more often, they end up controlling less when they should relative to the previous pilot. And so I think this idea of risk, like I'm wondering if that happens before they ever start planning, because if they do, then it would suggest the opposite of what we found. But if in the process of planning, they somehow incorporate this aspect of risk, maybe because we exclude one goal and it's just a depth of 3, a depth of 2 here for the thermometer and a depth of 1, maybe that exerts less of an effect. But to be honest, I'm not sure, and it's a great point. Yeah. Okay. Cool. All right. So like in the previous pilot, there's evidence that they're giving up control when they should. And in our Hayek-Bayesian model, we found evidence that when at the point when they should start to plan, for subjects that decided to regain control on those trials where they should initiate planning, there was greater reaction time. So this is the posterior estimate over that parameter, and the posterior highest density interval as well outside of 0. Okay, so it seems like delayed control does indicate delayed planning in this simpler task. And then finally, we see, I mean, again, the sample size is so small, but it's encouraging to see that it's replicated, that the extent to which you worry is associated with worse scores on our optimal delayed control scale. So the more worrying you are, the worse you are at delaying control when you should and delaying planning when you should, presumably. And this can't be explained in this study by more or less knowledge of the map, at least as measured before they started this phase, because everybody was at the ceiling. Everybody knew the full map. They knew all the trajectories well. Okay, so I would call this finding, mechanistic. It's predicated on an understanding of planning from a reinforcement learning perspective. And we might get more precise about the algorithmic basis for the observed phenomenon and worry that they are over planning, but it doesn't really explain like causally how this failure might develop in the first place. Why is it that worriers might have more trouble if you accept this preliminary data with delaying their planning when they should? And so I just offer 2 hypotheses to follow up on, which is that maybe an intolerance for uncertainties, so giving up control in the first place is something hard for these individuals to do, so they don't even consider this option of delaying planning. Maybe it comes with a cost. Maybe giving up control comes with a high cost that competes with the incentive to give up control, and so they don't do that. Or maybe there's actually sampling biases, like if they have more confidence in one route towards the goal, they stick with that. They don't want to risk screwing up, basically, because they're less confident in their ability maybe to find another route, which is probably necessary to, at least for some ways of thinking about this algorithmically, how people infer when to delay their planning out the full map might be necessary for that. So maybe that's why they fail to delay their planning. Okay, Daniel.
Yeah, sorry. Doesn't this in some sense have to be like one of the, so not necessarily one of those two options, but just to make sure I understood correctly. Like you tested
Sure.
them on all the trajectories and they know them all. So it has to be a choice, basically, right? Like it has to be some sort of internal decision process, you know, conscious or not, to not plan, right? Or am I missing something? Like, in which case it's something about the cost structure and the, you know, the different factors? Or do you not think that interpretation?
Yeah, I'm just not sure if I understand the question. So you're saying because we know that they know how to plan out all the routes, it has to be a decision that what?
That they're making, you know, based on some sort of third factor, as opposed to something that is a lack of capacity, right? Like, because if we're saying that we know the entire transition structure, or I mean, sorry, we're saying we know that they know the entire transition structure, then they must be, you know, not using that for some reason.
Yeah, for sure. Yeah, I guess I just got tripped up on like whether it's a decision. Like you know, in that quiz phase, everything is explicit, everything is overt. We're forcing them to look at an entire trajectory and, you know, say how to get from A to B to C to D. And now when there's this freedom to simulate whatever you want to simulate in your mind as you face these planning trials. Yeah, I guess conscious or unconscious, yes, there's something going on that probably limits them from simulating what is necessary to make this key inference of when they don't need to initiate planning. Yeah.
Yeah. Okay. I'm just trying to be super crisp about it. I'm just trying to make sure I understand, you know, why we might talk about it as can't versus don't type, you know.
Okay.
Because I'm a little bit confused about that. And it sounds like you're just saying don't rather than can't.
Yes. Okay. That was much clearer. I get it now. I would say,
Okay.
I think it's they don't, it's not that they can't. I think we've established they have the requisite information to be able to make that inference, and they're not.
Okay.
I think, but yeah, maybe others have other components that we're not getting at with the quiz that might be some lurking other reason for why they have a lack of a capacity for something in this.
Yeah, that was sort of
yeah,
exactly what I was wondering.
Just to chime in there, I mean, that distinction of can't versus don't, it reminds me of in executive function, they often talk about a knowledge action dissociation, where like frontal patients or kids, when they're developing, they show examples of perseveration, like the A not B error or other things like that. But when you try to quiz them for like whether they understood the task, maybe not the A not B, but the card sorting cases, they often do show that they know it. But you know, there's pushback on that dissociation too, because like if you ask them knowledge-based questions when there's conflict in the question, so instead of just saying explain me the rules, you say, you know, you provide the rules with some incongruency. They show the same problem with the sort of assessment of knowledge when there's just as much conflict in the question as there is in doing the task. And so it could be that something like that is present here, that when you do the quiz, like you're saying, everything is explicit and it's in front of them and you're constraining the paths that they have to go through. And so then it's easier to sort of reveal their knowledge than when they have to sort of freely simulate. Even a somewhat tweaked lack of knowledge would then make it harder to go through it. I don't know, something to consider. But my real question actually is, can you just go back to your first slide on, or just a couple slides ago?
Sure. Oh. Huh. Sorry, it's delayed for some reason. I'm not sure what's going on.
If not, I can hold it off.
You know, I'm sorry. It's for whatever reason, it's not letting me transition through slides. Let me just kind of.
There it is.
Okay, now we're getting it. Okay, is this one good?
Yeah, I mean, it's even more evident in the last experiment, but I think that this will be sufficient.
Okay.
So if you look at depth 1, Your data, and again, especially in the last experiment, is pretty beautiful in the sense that like they show the patterns that you predict, but it's also monotonic. So here you see it for depth 1, where they defer planning until the last one, but they also like slightly less at depth 2 in the depth 1 thing. Do you see what I mean? Like it goes up. Yeah,
Yeah.
from there to there, there. And in your last experiment where there was 4 levels, you saw that even more clearly. And I'm just wondering whether there's something, whether that's diagnostic of something related to the forward versus reverse planning, and whether there's a difference in the worriers in that pattern.
Yeah.
I don't know,
Yeah.
is that something you thought about? Because of course, if they're optimal, they would show the pattern that you're showing here. But for depth 1, I guess the first 2 would be flat. I mean, and then they could be suboptimal by raising that overall level and not deferring control. But the fact that they sort of parametrically increase it seems like it should reveal something there. And in the last experiment, you could see that at all the levels.
Yeah.
Yeah.
Right.
Right there.
Right. Yeah, it's more stark here for sure. Yeah, I haven't yet thought about this. I literally have started to think about how this incentivizes backwards planning today. So so yeah, I have a slide about this, and I go through why backwards planning, is optimal to realize, that you need to start at a certain decision point in planning, and how encountering a fork in the road when you're doing backwards planning would reveal information about like, you need to start planning at this stage, but you don't need to before that. And I'm just thinking about whether or not the use of backwards planning in some way relates to their ability to make these key inferences of when to delay planning, because I'm sure as you pointed out, and as I realized earlier today, it's much harder going in the forwards direction. So I think, but I haven't tied that to the pattern of this monotonic increase in the control data. So could you say just like a bit more, because I think my working memory demands are a bit lower. Yeah.
It's rather just of a thought at this point, but I think if so they should know that they don't have to do anything until they get to the last point at depth 1, for example, right? And so right now it looks like at the first stage they say, okay, I defer. But then as they get closer to the point where they need to plan, it seems like they're not giving up control as much on some trials, I guess. And that might mean that at that point, I guess what the question is whether it reveals one of these sort of chunking things where they sort of cache the values backwards from the reward in order to, or backwards from the goal in order to make that decision about giving up control. But I'm not sure that makes sense either, in the sense that they've learned the 1-step transitions before there was any reward. So there was no there's no sequential dependencies that would make them start from the goal in their initial chunking. That's why my question is sort of a gist thing. I think it's interesting that you see that pattern, and it must mean something. And so I guess I'm just saying, think about that some more. And it would be interesting to see whether the worriers look different in that. Are they the ones that, I mean, I know you only have a small sample at this point, but if you plot maybe the median split on worrying, just see what that pattern looks like, maybe it would give you some clue as to whether that is relevant to the distinction or if it's something orthogonal to it.
Yeah, no, it's great. I mean, just to even be aware that exists descriptively in the data, it was hitting a blind spot for me, and some of these preliminary potential explanations, are going to be useful as we try to explain this effect, because it really is, like you said, strikingly apparent in the previous task, and the fact that it holds is also striking. That's great. That's great.
I guess, it also could be something that you see across subjects or within subjects, right? It could be that some subjects that should be giving up control at stage 1 only do it fully at stage 2, and some do it at stage 1, and then when you plot the average, you see it like that. Or the same thing could happen within subjects, so that would be also worth looking at.
Yeah, I mean, right now we just have a little bit of within subject data that I've been sort of trying to parse descriptively to try to get intuitions and starting points for formalizing what's going on. So like a very, very crude sort of distinction is like, you know, are they figuring these optimal decision points to delay planning like in one shot? Or is it a sort of gradual process? Like, would we see their ability to delay planning optimally get better over time as they experience this goal more and more, right? Because they have 20 repeated experiences with each goal. And so here's just breaking down the subjects that had like a meaningful score that was like above the sort of the null of 0.5, whether broken down by the goal. So the goal here is, you know, depth 1 goal, depth 2 goal, depth 3 goal. And I would have expected perhaps more of a gradual effect. Seems like for these middle subjects, they're not really changing at all. They made their key inferences at the beginning. You'd probably see it most dramatically here and here, right? These are the only 2 subjects that show with more experience with a given goal, they're getting better at delaying their planning and control, and they should. But you know, when we take the group average, for instance, which is here, it's slightly positive over time. They're getting better at delaying their control, and they should, but it's pretty negligible, I guess. We need to get more subjects to see this. But yeah, this is the first thing I did when I started to think about, you know, how they arrive at the inference. Is it gradual, or is it something that they're inferring quite early on? Yeah. But yeah, one of the ideas I had with this sort of backwards planning is yeah, if we look further into this as an individual difference measure, if we see that kind of monotonic increase, like you pointed out, being somehow related to backwards planning, if we can reason that through, then maybe those are the people that are doing better at the task. And from the beginning, we thought about using neuroimaging to try to get at, you know, a relationship between this popular sequential reactivation sequenceness. It has many different names, but the idea that people are replaying or, you know, pre-playing the action sequence they're going to take before they execute their action. And part of this project was establishing good decoding for all the images that we use in the cognitive map. So we have plans to put that in place this, you know, soon. But first, we want to get a better hold over how exactly this inference is being made computationally.
Yeah, that's cool. I was just thinking about there's a somewhat of a relationship between so Alana Jasker is a grad student in the lab who's not here because she's teaching in an RL workshop right now downstairs, but she's doing some work on reward predictive representation. So like if you have to compress a high dimensional state space in a model-based environment, you can collapse across different states if their ability to predict the sequence of rewards that you get conditional on your policy is equivalent, then that's an efficient abstraction to make the transfers. This is based on Lucas Lehnert's work. And it seems like in your case, the situations that allow you to give up control are also equivalent in terms of reward predictiveness. So she's going to look at replay in that situation to ask whether you tend to develop similar representations for things that are equivalent in terms of reward predictiveness. Yeah, just might be interesting to think about the relationship between what you find and what she's doing.
Yeah, it's interesting actually. As I was putting together like my job talk materials, I've been thinking a lot about state abstraction and how that might go awry in worry in specific ways. So it's something that's in my head. I haven't yet connected it to this paradigm of delaying planning. But yeah, I would love to hear more about it. And by the way, just as a technical note, I use my phone as Wi-Fi, and I got a call in the middle, so I missed like the middle 10 seconds of what you said, but I think I got most of the gist.
Yeah, you probably got the state abstraction there. Actually, the thing that might be different here is that there are two states that are equivalent, but only conditional on the goal. Whereas in the kind of situations that we're interested in is like they're states that are equivalent to each other for being able to predict reward sequences conditional on your policy as a whole. And I think in your situation, that's probably not the case because they're only equivalent depending on the goal. Anyway, this is a bit of a sidetrack.
Yeah.
I just thought it'd be worth mentioning the relationship. Maybe we can talk about that another time.
Yeah, that would be great. So just like one really quick follow-up. So in these paradigms, does the reward function remain stable?
No, the point
so
of
the goal changes.
the abstraction is that if you learn the correct abstraction, you could apply it to a new MDP that has a different reward function and a different transition function. But the reward function, but it does have to be stable for the purposes of compressing in the first place. Yeah, I think probably would require elaborating a little bit more, or I can send you a paper and we can talk about it offline.
Yeah, sure. I appreciate it. Cool. I kind of jumped around a bit, which I think is fine. It followed where the questions led. But just to fill up some time, please jump in if you have a question. But just as sort of a recap of everything, we found these two relationships that go against the prevailing sort of interim conclusions in computational psychiatry on the relationship between planning and anxiety and worry, which is that worriers have problems disengaging punishment avoidant planning when we think about planning in a multi-goal context. And it seems like, having replicated this twice, that there's a relationship between worry and delaying planning, which would explain why worriers come into the clinic and say they're so exhausted from their worry. One source of that exhaustion could be using costly planning when you don't have to, and just continually incurring that cost. And so, yeah, if I feel like I've already gotten more useful sort of next steps for formalizing how people infer when to delay their planning. And if anybody else has any ideas on that end, either now or feel free to email me and we can talk offline.
Well, I had a question about, or just a quick thought about, so I know one of the main things that you manipulated in the pilot was to reduce the, I guess, the stress that people experience while they're going through the task. But do you feel like I guess, there'd be a residual concern about whether, your worriers are showing decrements in their ability to sort of optimally relinquish control as a function of their having higher stress in the task. And I wonder if you have a way of controlling for that.
Yeah, it's a great point. I think it's a lurking confound in a lot of studies that whoever happens to be more stressed is going to take a hit on what is most cognitively demanding, and delaying planning, whatever that inference is probably the most cognitively demanding thing they have to engage in this task. So I think as of now, we could try to statistically control for getting their stress measures, maybe like before and after the key phase. I think it would be interesting to think of other sort of like similar planning phases that maybe remove the decision between do I give up control or do I not, and have them sort of engage in the same sort of goal switching, but make it quite apparent that all they have to do is plan in some way. I don't know. I haven't really thought this through yet, but maybe there's a different sort of planning phase where we can try to keep the stress somewhat equivalent, but remove this, requirement to delay their control and meta plan, and see if like, planning suffers or something in that context, to just see like if they're just more stressed at that point, if they're if that can explain what we found. Yeah, but I'm not entirely sure yet.
And then I guess on a related note I was thinking about the paper that Ross Otto published a few years back showing that if you have higher, I think, working memory capacity, I don't remember the exact measure, then that's protective against the deleterious effects of stress on planning. And so I just considering working memory capacity as an important individual difference covariate here.
Yeah, I think for sure, as we gear up for a bigger study, as Daniel mentioned also before, as a key individual difference, I think when you guys were offline, I think that will be key to distinguish, variance associated with worry and variance associated with what seems like, would predict differences in performance across individuals in this task for sure.
Totally.
Yeah,
Just
thanks.
Beth, did you find any, did you get any ratings of stressfulness? Because the pilot one was was where you were showing the decay in the points that you're going to get, and then the other two you didn't use that, right? And did you find that actually people were less stressed out by pilots 2 and 3 because that was removed?
So any statement I made about stress was like was a guess. We didn't measure stress at all. It's a guess to explain why under that context people in general didn't make this key inference. It's like, you could think of stress attacking higher cognitive functions, and for people that weren't worriers, it attacked the highest cognitive function, which is this meta control. And for people that did worry, it sort of attacked both. It attacked meta planning and planning. And then when we remove that stress, it seems like planning is intact, but it's just meta planning that gets affected. And if stress, it gets pretty confusing, because there might be reasons why stress for worriers might be related to intolerance of uncertainty, and it's ultimately that which explains their failure to delay control when they should. And that to me is much more interesting than just stress in general. So it would be interesting to have a stress induction that was, we would still be confident that we could see interesting variation in meta planning, in delaying planning. But it would be whatever the specific kind of stress the worriers were experiencing maybe is what is the ultimate cause of a specific failure.
That reminds me of the connection to something Pete is interested in also, on the model of contrast avoidance for worrying. So a fundamental conundrum there is, I guess the idea is that you put yourself into a negative state so that if something bad happens, the prediction error doesn't feel as bad. But from an RL perspective, we've talked about how that's a bit of a paradox, because you would have a lower negative prediction error when something bad happens, but it's still negative, and you're in the negative state all the time in advance. And if you had to take the integral of your negative value over all the time, it would be worse if you're just worrying all the time, even though most of the time nothing bad is happening. So the question is, why is that happening? We have some, thoughts about that, but does that relate to the inability to delay control as well? So even though you should delay control, they're not. Just like even though you should delay worrying, essentially. You should delay feeling in a negative state because bad things only happen a rare portion of the time, and most of the time you can't avoid them. So did you think that there's like a relationship between those things?
Yeah, that's really interesting. I haven't made that connection in my head yet, but I think there's something really promising there. Yeah, I mean, just thinking along the lines of this model that I always thought was kind of funny, intentionally putting yourself in a negative state. Like, for instance, like even the idea there, right? If you have chronic stress, chronically negative state, there's probably like a time course to other systems that are affected by that, which then induce like negative prediction errors. So, it's somewhat of a simplistic reduction to say that like, if you put yourself in a negative state, you've sort of encompassed the only possible prediction, right? From
Right,
which
yeah.
you then are, removing
Depends
this
on whether
future surprise.
prediction errors are scalar or vector, I think.
Yeah,
But-
yeah. But I
Yeah, but I
think,
think that, sorry, go ahead.
yeah. No, go for it, Pete.
Well, I mean, I think the way the reason I think that theory has some face validity, even if the experimental evidence is not good at this point, is that it's just this sort of idea that there's these very strong prediction error experiences that are extremely salient, that are quite different than and a lot more salient than the sort of integral over your negative affect, right? So that people get extremely motivated by these these things when they have really strong violation that like leads to a precipitous drop in their affect. And if it's, and you might be a lot less, even if it's true that to some extent there's some sort of accommodation in other systems, and you dropping yourself to a lower level forces other kinds of negative prediction errors, then I guess because you're less responsive or something like that, then that still might be a lot less salient than what's when you have a very, very strong experience relative to like feeling neutral, or even especially when you're riding high, because that's the type of thing that people come up with explanations for, that like it was just when I really the other shoe dropped as soon as I sort of let my guard down or something like that.
Yeah, so there's some prioritizing of avoiding some catastrophic prediction error, even if there are these other ones, something like that. Yeah, I think there could be some story here where there's like a misconception from a decision theoretic standpoint of costs and benefits, and like there's some, maybe it has to do with things that are just unobserved, like internal reward functions and some incredibly high cost to uncertainty, as being part of why they're pursuing this policy to engage control, to over engage control. Yeah, not sure. Maybe that's somehow related to the contrast avoidance model.
Well, I need to run. Anyone else who might be interested, there's this International Food Day at Kearney that we can I want to get my lunch there, but thank you. Anybody else
Cool.
does, but you don't have to run right now. But this has been super interesting though.
Yeah, thank you so much, Michael, for and everybody for the invite. Yeah.
Oh,
Thank you guys.
really quick. Paul, you said that you needed to kind of reschedule the individual meetings tomorrow.
Yeah, it's just that I just have to leave it at 11:30. I actually have a meeting with Pete. So I can do any time in the morning until 11:30. I'd love to meet with those who want to talk more.
Okay, and I'll
See ya.
Thank you. Great, thank you so much.
Thank you,
Yeah,
Paul.
cheers, thanks.
Really appreciate the awesome talk.
Yeah, thank you guys. Thanks so much for the great questions.
All right, bye.
All right, see ya.